Hello, welcome for the week 12 assignments. This is the last week. So, week 12 assignments. So, the first question is for a sequence that is x of n that is equal to minus a to the power whole n u of minus n minus 1 determine xz x of z for mod of z less than equal to mod of alpha. So, just let me solve it. So x of n equal to minus alpha to the power n u of minus n minus 1. So x of z is equal to n equal to minus infinite to infinite minus alpha to the power n u of minus n minus 1 to z to the power minus n. This is actually equal to minus infinite to minus 1 minus alpha z whole inverse to the power n. So this is a GP series. So that will be equal to for all r that is mod of r less than equal to 1. This condition holds. It will be minus alpha z inverse whole inverse by 1 minus alpha z inverse whole inverse. This is true for here r is this whole term. So for alpha z inverse whole inverse this r less than equal to 1. And following this, we can write this is equal to minus 1 by alpha z inverse to 1 minus 1 by alpha z inverse. This is for all minus alpha z inverse whole inverse less than 1. Or the simplified form, we can write it is equal to minus 1 by 1 plus alpha z inverse for z less than mod of alpha. And this is equal to minus z by z plus. This is the answer. Now let us go to the question number 2. Two is like this. There is 0 here. So this point is 1 by 2. This, sorry, you should not mention this one. So this is half. This is 3 by 2. This is 1 by 3. The ROC in this is in this direction, outside of this. So what is x of z? It's easy. We know where are the poles and where are the zeros. So it is 0 at z equal to 0. Another 0 is at z equal to 3 by 2. Similarly, one pole is at z of 1 by 3. Another pole is at z minus half. Poles are the denominator and zeros are in the numerator. This is the answer. Now the next question is determine x of n for the same thing. So we know what is x of z. From this, we have to find what is x of n. Now, just derive the x of n. Now, so once again, I'm writing what is x of z. This is equal to z into z minus 3 by 2 by z minus 1 by 3 into z minus 1 by 2 times. So from this we can write sub z by z is equal to z minus 3 by 2 by z minus 1 by 3 with z minus 1 by 2. So this is actually a by z minus 1 by 3 b by z minus 1 by 2. So if we solve this partial fraction, then using partial fraction, we'll find that a is equal to 7 but b is equal to from this x of z by z you can write as 7 by 7 by z minus 1 by 3 plus minus 6 by z minus half, which is equal to 7z x of z now is equal to 7z by z minus 1 by 3 minus 6z by z minus 1 by 2. So from this we can write x of n 7 times this the formula for a to the power n un 1 by 3n u of minus 6 up to the power n un. This is the x of n value. Now let us go to the fourth question. Now I'm drawing first a circle. Now radius. To and this is the arrows. Just imagine it. It's the so here is one ROC. Here is one ROC. Another ROC is here. So there is inside this circle ROC is we denote it as ROC 3. We denote it as ROC 2. And the outside ROC is ROC 1. And this is 1 by 3 point. This is 1 by 2 point. So we have to match this section. So ROC 1, ROC 2, ROC 3 is in the left hand side. 1, 2, 3. The right hand side there are A, B, and C. 3 points. So we have to say the signal is both sided. What is the characteristics of the signal? It is depending on the ROC. Option B, right sided. C, left sided. Surface. So what is the sequence of X surface? That is the question, depending on the ROCs. Okay, let's draw it once again. This time, exhaust. Step draw this and this. Then take this small circle, big circle. And then I denote the ROC this way. This one of the ROC. This is one ROC. And the black one is. So now this is the ROC1. ROC1 we can write the circle, this circle is outer to the outermost pole. So this is right-sided signal. So number one here is B. One is B. So we can write one is B. Similarly, ROC2 this is the ROC2 and this is outer to the pole half and inner to pole 1 by 3. So both sided. And ROC3 is the left sided signal because it's only the inside the outermost pole. Sorry, it's not outermost, like Z equal to 1 by 3 pole and side. So for ROC3, these are left sided signals. Now let us go to the question number 5. Question is, for a real valued signal xn, x star of n in z domain is the four options A x star z, option B xz, option C x star minus z, Option D, X, Z star. So X of n star is equal to X of n because X of n is a real valued signal. Now, if X of n has a DFT, X of Z, then X star n should also have a DFT, X of Z. So option B is the correct. Now, let us go to question number 6. Again, we have to draw this one. This was the ROC. Hello, some poles, zeros, 1, 0, 0, and 1 by 3, and half, and 3 by 3. So, determine the causality and stability. So, again, just comment ROC is outer to the outermost pole. The system is causal. and this ROC contains the unit circle. So it is stable. The system is stable and causal. Let us go to question number 7. So question number 7 is like this. So this 1 by 3, this is 1 by 2, this is ROC 3, this is ROC 2, and the most outer one is ROC 1. So we have to comment on causality and stability. So we'll solve this by one by one. So for first, we should consider about ROC2. So ROC2 is this one. This does not contain unit circle, and also that means it is unstable, and it is inner to the outermost core. So non-causal. So this is unstable non-causal. Now just ROC3. So it is inner to the innermost pole. So it is still non-causal, but it also does not contain unit cell. So it is also unstable and non-causal. So this one, that is RS3, is unstable and non-causal. Now let us go to the ROC1, that is outside. For ROC1, it does contain the unit circle. So this is stable. And it is also outer to the first, it is ROC1, outermost. So it is also causal. So this is causal and stable. So for different ROCs, it may be unstable and non-causal and causal and stable. Okay. So the last question, question number 10. For a possible stable and causal system, choose ROC. Now I am giving what is its object. that is equal to 1 by ns z to the power minus 2 by 4 by 1 plus z to the power minus 2 by 4 plus 1 plus 5 z inverse by 4 plus 3 z to the power minus 2 by 4. So it is 8. So now I'm just drawing it for the convenience. This is the circle. Circle. There is a pole here. There's a pole here. There's a pole here. Pole here. No pole here. Just let me draw in the next. Now I'm just writing what are the poles. It's minus 3 by 4. There is a pole. There's the pole at here and here. This is plus j by 2. This is minus j by 2. Another pole is at here. Minus half. So the inside is ROC 3. The outside again, this ROC is ROC 1 and the middle one is again ROC 2. So again, the answer is ROC 1 because to be stable, it should be ROC must contain unit circle to be stable, and also it should be at the outer of the outermost pole. So the correct option is ROC 1. So this is all for today. Best of luck for your exam. If you have any doubt, you can mail me. Thank you.